Algebra is made up of two ideas. The two ideas that makes up algebra are what we call groups and operations. Okay, groups and operations. I'm going to give you an example of an operation. You give me another one. Operation of addition. Give me another one. Give me another.
Multiplication.
Give me another one. Give me another one. Exponents. Good. Give me another one. Square root. Good. Give me another one. Absolute value. Give me another one. Sine of something. Give me another one. Log of something. Those are all operations, are they not? Those are all operations, and you spend a lot of time in algebra learning about operations. And that is a primary focus of algebra, is operations that are used. But what do we operate on? What are the things that we operate on most of the time? Numbers, right? All real numbers. We're using numbers like 3, 4, 5, 6, pi, -1, 25 over 3, whatever. But there are other groups as well, such as like x plus 1 times x minus 2. You multiply those two groups together as they are both what we call algebraic expressions. Okay, so we got numbers are groups, algebraic expressions are groups. I'm going to teach you in the next few days two operations that you don't know yet. They're operations you don't understand, you can't think about, and the group that they apply to are functions. F and G. Okay? So, groups, operations. So today our group is functions and our operation is addition, subtraction, multiplication, division. Again, I'll show you two new operations you don't know later on. So, how do we add two functions? Very simple. We just take f of x and we add it to g of x. First part of this is going to be nice and easy. Notice my first problem here. It says to identify f plus, f minus, f times, and f divided by g. So I'm going to write f plus g, f minus g, f times g, and f divided by g. Last hour did an excellent job of stopping me a few times and asking me questions. Please make sure if you have one, stop me. There's a lot of good questions that could come up in this section, okay? So when I add them together, I just take x squared and I add x minus 1. Are there any terms you can combine? No, so it's just x squared plus x minus 1. If there were terms you could combine, then you combine them. What do you get if you subtract those two things? X squared?
Minus x plus 1.
Minus x plus 1. How'd you get the plus 1?
Because you multiply or you factor it out.
Distribute
the negative.
The subtraction side. Good. Ben distribute the subtraction sign all the way through. You got that. Next one, we multiply. I've got x squared times x minus 1. X squared times x minus 1. I mean, it has to be right without parentheses. You get x cubed minus x squared. Then you have f divided by g, and we have x squared divided by x minus 1. And this is where you come to me on the test. You say, hey, Mr. Gens, do you want me to cross off the x's? And that's where I smile at you and I say, that's a great question. Go sit down. Okay? I'm not telling you the answer to that. That's the measure of you as a master. You got to know. Can you cross off those x's? Absolutely not. Okay? All right? But I'm not telling you that. You got to know that yourself. The second thing we want to be able to do, because that was pretty easy, wasn't it? It's pretty easy. The other thing we want to do is be able to identify the domain of each one. And so we're going to bring back the topic of a domain. And some of you did very well on domain from your test. Some of you didn't do as well on domain on your test. So just to review here, we can subtract these. We can multiply these. And we can divide these. But the way that we calculate domain is we use this. We find the domain of f, and we intersect it with the domain of g. Domain of f intersecting domain of g. Now I write it, and you can probably repeat it, but the question is, do you really understand what domain of f intersect domain of g is? And probably not. So we're going to investigate what that is so you can understand what this domain is going to be. I'm going to put a number line right here. Okay, we'll put 0 right in the middle. What is the domain of x squared? Do you remember from your test, what would you say is the domain of x squared?
Negative infinity, positive infinity.
Why?
Because it's like a parabola.
It's a parabola, and the domain is all real numbers. Yeah, just continues to go on, right? Notice that there's no restrictions on those domains, are there? Are there restrictions on domain here? Yeah, when you have square roots, those cause problems, right? Big problems. Are there restrictions when you have fractions? Yeah, there are, right? So we have restrictions there, but up here, we just have two polynomials. So notice that the domain of x squared is all real numbers. I'll represent that with the green line. And then the domain of x minus 1 is also all real numbers. I'll express that with the yellow line. What is the overlap of the yellow and the green?
All real numbers.
All real numbers. Everybody agree? So therefore, the domain of them being added together is all real numbers. And it's also that way for subtraction and multiplication. So when you compute domain, it's the same thing for subtraction, it's the same thing for multiplication, and it's the same thing for division, except we must exclude the domain of g equal to 0. All right, so let's look at the bottom one. We'll look at this bottom one right here. We divide, and we say, well, the domain of x squared is all real numbers, and the domain of x minus 1 is all real numbers. But I have to remember, what number can we not divide by? 0, and the number that would produce 0 in the denominator is what, Evie?
1.
So therefore, this says we have to exclude 1 from our domain set. So we say that x cannot be 1. Okay? Now, we start the most basic example working with polynomials there. We want to move over to radicals and see something that's just a little bit different. So I'm going to erase this. You might have to make some space for yourself because I need a little bit extra room. So in your notes, you might have to write a little bit smaller or use a separate sheet of paper or something. I don't know. Just don't complain I didn't make the notes big enough. That starts to make me crabby. So here we go. We got f plus g, and we got f minus g, we got f times g, and we got f divided by g. Okay, so rules are a little bit different now as we have radicals. Are you allowed to add two radicals if that part is not the same? No, you're not. So all you can do with this is just write the square root of 2 minus x plus the square root of x squared minus 9.
Can you simplify?
How would you simplify?
Wait, whoops. Well, you would take factor out x. You could do plus x square root of negative 9.
Okay, I get what you're saying. If I could bring you to that point, these are the questions I want you guys to ask. Okay? If I had the square root of, say, 5x squared, what I could do is write that as the square root of x squared times the root of 5. And that would give me x roots of 5. Notice that it's written as multiplication. Here it's written as subtraction, so you can't factor that out. Does everybody see? Okay, that doesn't apply there. Okay, great question. That actually came up last hour as well. All right, so then I'm going to look at subtraction. Same rules apply. I've got the square root of 2 minus x, and that's going to be minus the square root of x squared minus 9. Are you allowed to multiply them together? For example, can you take the square root of 2 times the square root of 3 to get the square root of 6? Is that allowed? Absolutely is, right? Yep, you can definitely multiply two radicals together. So I can multiply these together and create one radical. 2 times x squared is 2x squared. 2 times negative 9 is negative 18. Negative x times x squared is negative x cubed. Negative x times negative 9 is positive 9x. All underneath one radical. Everybody okay with that? And same thing works with division. You could write them under one radical as well. I have the 2 minus x on top, and the bottom I have x squared minus 9. Now I'm going to list the domain of each of those. Right now, with you and those around you, see if you can come up with the domain of f. Come up with the domain of f on your own. This is from your last test. Come up with the domain. Go. Talk.
Of f. Alright, so 2 minus x.
Yeah.
Greater than or greater than 0. Subtract 2 if you want to just get rid of or just add x. 2 is greater than or equal to x.
So at least.
Oh, yeah.
Okay, you should have 2 minus x is greater than or equal to 0. Subtract the 2. Negative x is greater than or equal to negative 2. And you divide by a negative, you get x is less than or equal to 2. So your domain is going to be from negative infinity to positive 2. Are there any questions how I came up with that? Why did I set it greater than or equal to 0? Because you can't take the square root of a negative number, okay? So I ensure that if I'm going to plug in anything between negative infinity and 2, that that's going to be square root of a positive number, okay? So that was the easy one. Let's do the more difficult one. I also have to say x squared minus 9 is greater than or equal to 0. Well, that's a nonlinear inequality. You can't just subtract 9 and square root and stuff like that. If you have something that's nonlinear, you either have to make a graph or a table. You guys know what that graph looks like? I hope so. What shape does it make? Parabola. You know what it looks like. Goes through positive 3 and negative 3. And it's right side up. Am I wondering where that's above the x-axis, or am I wondering where it's below? Above, because we're wondering where it's greater or equal to 0. So the domain of this one is from negative infinity to negative 3, union 3 to infinity. Okay, that's what we got. Hi, thank you. So that's what we've got, okay? Negative 3, negative infinity, negative 3, and 3 to infinity, okay? And then we've got negative infinity to 2. So what I'm going to do right now is I'm going to look at a graph, and I'm going to look at those overlaps, okay? I'm going to plot some numbers. I'm going to plot negative 3. I'm going to plot positive 3. And I'm going to plot that positive 2. I can see that this domain right here can be expressed as a graph like that and like that. And the other domain of x less than or equal to 2 can be expressed like this. I'm looking for the overlap. Do they overlap here? Do they overlap here? Do they overlap here? Do they overlap here? So from negative infinity to negative 3. So I got negative infinity to negative 3. Negative infinity to negative 3. Negative infinity to negative 3. This could be the same for the first 3. How about the last one? Talk to your partner 30 seconds. How is the last one going to be different? See if you can figure it out. Go.
Okay. Alright. So we just can't have we can't have the 3 there because that's like 0.
Yeah.
So I said,
Yeah, you can't do
No, you can tell everything.
X cannot be equal to 3.
5, 4, 3, 2, 1. Heard a lot of good thoughts. The domain wants to stay the same. It's just got to exclude any values that would produce 0 in the denominator. What values produce 0 in the denominator?
3 and negative 3.
3 and negative 3. Is 3 included in that domain?
No.
No, 3 is not anywhere in there, is it? So I don't have to worry about 3. Is negative 3 currently included? I got to exclude it. How will I exclude negative 3?
Brackets or parentheses.
That's it. So the domain for dividing is often going to look very similar. Just maybe one little change. Okay? The last one involves fractions. You like fractions? You're going to like these. These are nice and easy. I've got f plus g, f minus g, f times g, and f divided by g. I don't want you to focus on the domain at all. What I would like you to try to do right now is write the addition of these two and the subtraction and the multiplication and the division. Try to write those 4. Take about 2 minutes, see if you do that, and then we'll go through the domain.
Yeah. X minus 1. And X minus 1.
What's your language?
For real, that's what people are. I hope you don't do your job.
Wow, okay.
You was with our first time, have it?
Really?
Well, he's gonna.
Nah.
You probably got the job. You don't have
Okay, you should have 4 plus 2x over x minus 1, because did you notice they had common denominators? Is that nice that they have common denominators? Like, thank you, Mr. Gintz. We love common denominators. Well, you're welcome. 4 minus 2x over x minus 1. And we multiply the top to get an 8x, and you multiply the bottom to get an x minus 1 quantity squared. Do you remember the square of the bottom? If you wrote as x squared minus 2x plus 1, that's fine as well, but you got to multiply them together. And then the last one for dividing, you have 4 over x minus 1. You divide that by 2x over x minus 1. Somebody's first hour said, oh, I kind of remember doing something like this. Well, yeah, this is a complex fraction. In order to simplify a complex fraction, you need to multiply by the reciprocal. Before we do that, I want to talk about the domain, because it lends itself right to this last part. Domain. Domain is nice and easy. For this problem, super easy. Okay? It's the square roots that sometimes give us a problem. What's the domain of this one?
X cannot be equal to 1.
X can't be 1. What's the domain of this one? X can't be 1. What's the overlap between X can't be 1 and X can't be 1? X can't be 1. It will always be the same for the first 3. Now here's where you got to be careful. Is in the last one, okay? I'm going to do my best to teach on this. This is not easy sometimes for a teacher to figure out, okay? Notice x minus 1 is in the denominator. Everybody agree? And notice we have another part. We've got this x minus 1 also in the denominator, right? We've also then got this piece right here. We've got a denominator right there. Is that not also a denominator?
Yeah.
Okay, so I'm going to point to them. This one right here, x cannot be 1. This one, x cannot be 1. And then look at this part right here. what would x be right there that would make everything 0 on the bottom?
0.
0. Does everybody agree if x was 0 right there? You'd have 2 times 0 is 0, divide by -1, and you'd get 0 in the denominator. So you can see from here that it is true that x, hey, wow, that really is not very attractive, is it? Let's try that again. Go away, go away, go away. All right, x cannot be 1 or 0. You have to consider the domain before you do any simplifying. Now you're like, well, Mr. Gens, I went ahead and I figured it out. Well, watch what happens if you work it through. 4 over x minus 1, and you're going to multiply by the reciprocal, x minus 1 over 2x. Notice how the x minus 1's go away, and you'll have to 4 over 2x, which is the same as 2 over x. If you look at just that, you would say x can't be 0. But you would have forgotten about the 1, wouldn't you? You see that? So you got to think about the domain before you simplify. Okay, before you simplify. Okay? All right. So turn to your homework. My good friend Ben Schultz is all caught up with his homework. Way to go, dog. Way to go. Woo! He's going to get himself a flannel shirt for tomorrow. Combining functions. Section 1. There's problems A, B, C, D, E, and F. But after that, we're not really ready to move on to the next part. That'll be the beginning part of tomorrow. So you can work on A, B, C, D, E, and F, okay? You should be able to get a little bit done right now. I do have the answer key posted up here. And by the time I leave tonight, so by later on tonight, you should see answers for all the answer keys posted online. Okay? Deal? Deal. Tell you what, I will post not just the answers, I will also post all the work if Connor comes to school tomorrow dressed up as Big Bird.
Just like this big bird.
Yeah.
And then I'll
Where am I
post
supposed to get a big bird costume?
Think about it. Be creative, man.
Just wear a few
How
yellow,
am I
yellow
gonna get 9
feathers.
feet tall? Or like however tall?
You're almost there.
He's big.
He's a big dude.